Hello, hello, welcome back for example 4. First, we need to talk about the Pythagorean Theorem before we get started on example 4. So, the Pythagorean Theorem is just like the distance formula. It's not going away. You're going to use it. So, this needs to be a flashcard. Hopefully, some of you already have it memorized. It's a lovely little theorem. So the Pythagorean Theorem is this. Pythagorean Theorem. In a right triangle, okay, so that's super duper important. This little thing right here means it's a right triangle. It has to be a right triangle. This only applies to right triangles. If you have another triangle that's not a right triangle, this doesn't apply. So only a right triangle. So in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay, a lot of terminology there. Okay, what you need to know is whenever you have this right triangle right here, the side that is directly, right triangle, I meant right angle. Okay, whenever you have this right angle, the side that is directly across from the right angle is called the hypotenuse. Hypotenuse. Okay, so it's this side right here. And with the Pythagorean theorem, they call that C. Now, the hypotenuse is always the longest side. Okay, it's always the longest side. Hypotenuse, C. Now, there's two other sides that are not the hypotenuse. So the sides that are not the hypotenuse, those are called the legs. So this is a leg here. Let me use a different color. This is a leg, and this is a leg. And you use the letters A and B for the legs. Now this can be A and this can be B, or this can be A and this can be B. It doesn't matter what's A and what's B. The really important thing is that this hypotenuse is C. Okay? So so in a right triangle, that's what we have, this sum, okay, that means we're adding of the squares of the lengths of the sides. So that means A squared, that's a square of a leg, and B squared is a square of a leg. So the sum of those two things, which means we're adding them together. So A squared plus B squared, that's the sum of the squares of the legs, is equal to the square of the length of the hypotenuse, which we're calling C, so C squared. So, all right, that is the Pythagorean theorem. So A squared plus B squared, those are the legs right here, and that is equal to the square of the hypotenuse, which is C squared. So put that on a flashcard, memorize it, you can do it. I always like the little picture, and then the theorem, and then the actual formula there. Okay, let's look and see how we're going to apply this in an example. So example 4, here we go. Example 4 states, finding distances in the coordinate plane using the distance formula and the Pythagorean theorem to find the distance from D to E. Okay, so it wants us to do two things. It's always super important. I like being able to highlight this, okay? On your quiz, you're going to have to do the same thing. So it's really important that you read the instructions and you highlight what you're supposed to do. So we're going to use the distance formula and the Pythagorean theorem to find the distance from there to there. So we're going to do two things, the distance formula and the Pythagorean theorem. Okay. I want to go ahead and use the Pythagorean theorem first because that's kind of new, and then we'll do the distance formula to check. But you need to be, for this problem you have to do both. You're going to have a quiz and you're going to have to do both. Sometimes people don't read and then they just do one and then they don't get full points because they didn't even do the second one. So it's just really important that you read the instructions so you answer the problem completely. So here we have D is here. D is 3, 4, and E is -2, 5 here. So what we're going to do when we use the Pythagorean theorem is we have our line segment right here. Okay, and this is what you have to do. So on your problem, you're only going to have these points, you plot them, and you are going to have this there. Okay, we don't have a triangle there. You have to make the triangle. So how you make the triangle is you take this point and then you go directly across. So it's a horizontal line. So you have a horizontal line coming this way. And then you have this vertical line going down, and you keep going until they intersect. And since this is horizontal and this is vertical, they are going to intersect at a 90-degree angle, which is that right triangle which we need, okay? So once we have that, now we just need to figure out, like up here, what is the A and what is the B and what's the C, right? So the C is what we're trying to figure out here. This is the distance. The A and the B we can figure out because this is on a coordinate plane. So I'm going to call this A, all right? This is going to be my A value. And I know that the, so it's really the distance of the X, right, from here. So this is my X value here at -2, and this is my X value here at 3. So it's the distance from -2 to 3 is going to be how big my A value is. So here, -2, so that's distance of 1, 2, 3, 4, 5. Okay, so if you look here, 1, 2, 3, 4, 5. That means that the distance of A is equal to 5. All right, so you just have to be able to do that. You got to be able to count. And then here, we're going to find the distance from this point. This is going to be our B all the way up here. So that's going to be looking at the Y values, right? So we have -5 and 4. So we know that this is 0, right? And to get to -5 means from here to here is -5, which means it's 5, right? So from here to here, this is 5. And also from here to here, this is 4, right? So we know 5 plus 4 is 9. So that means that B is equal to 9. Okay, so there is our A value and there is our B value. And we just did that by drawing this right triangle and basically counting up the sides. So that's how we determine. We have to be able to do that for the A value and the B value. All right, so I'm going to go over here. I'm going to write the Pythagorean Theorem. So this is the Pythagorean Theorem, A squared plus B squared equals C squared. I'm going to define my variables. A is equal to 5 and B is equal to 9. I'm going to substitute those values, and C is what we're trying to determine, right? That's the distance from D to E. Okay, so we substitute these values in. We get 5 squared plus B is 9 squared equals C squared. 5 squared, 5 times 5 is 25. Plus 9 squared is 9 times 9, which is 81, equals C squared. I don't know what that is off the top of my head, so I'm going to go over here and just do a little bit of 25 plus 81, plus 1 plus 5 is 6, 8 plus 2 is 10. So that ends up being 106 equals the square root, equals C squared. I'm going to use the symmetric property of equality, which would be C squared equals 106. So I need to figure out what C is. So I have to do the inverse operation of C squared. The inverse operation of a square would be a square root to both sides, right? So that square root and that square, they fruit ninja cancel each other out, and so we're just left with C equals the square root of 106. All right. So I need to determine if there is a squared number that is a factor. Okay, I want to put this in exact form. So what are my squared numbers, right? My squared numbers are, write this over here, 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, what's the other one? 6 squared, they just keep going on forever, right? 7 squared equals 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. So I want to see if any of these numbers here are a factor of 106. So the first one I'm going to look at is 4. Does 4 go into 106? Well, I know 4 goes into 100, right? 4 goes into 100 25 times. So if I was to count by 4s, it would be like once I get to 100, then it would be 104 and then 108, right? So that means 106 is not divisible by 4, or 4 is not a factor, right? So that squared number doesn't go into 106. So that means all of the other squared numbers that are factors of 4, like, okay, so this one doesn't work. That means 16 because 4 goes into 16, so that's not going to work. 36 is not going to work. 64 is not going to work. 100 is not going to work. So none of those are going to work. I can look at 9, and I can see if 9 goes into 106, which means it basically is 106 divisible by 9. Now, I don't know if you guys remember the divisibility rules for 9, but basically you add up the digits, 1 plus 0 plus 6, which is 7, and is 7 divisible by 9? It is not, which means that 9 isn't a factor. We can look at 25, right? But 25 goes into 100. The next one after 100 would be 125, so 25 doesn't go into that. 49, you know, 49 plus 49 is going to be 98, and so, yeah, that's not going to work. And then 81, nope, 81's not going to work. So really, none of these squared numbers are factors of 106, so that means this is the exact form just right here, the square root of 106. So that's our C, which means that the distance of DE is the square root of 106. Okay, so we determined that using the Pythagorean Theorem. Now we're going to do the, check this using the distance formula. And it's not like a check, it's like you have to do it 2 times, right? So you have to find it. I mean, we are checking our answer, but this is the whole like check. It's not optional. If that's what I'm trying to say. Like you have to do both. So you have to do the Pythagorean theorem, and then you have to do the distance formula. So we have these 2 points here. I'm going to call this my x1 and my y1, and this is going to be my x2 and my y2. And we're just going to find the distance of DE. So I'm going to write DE, and then I'm going to write that distance formula using symbols, which I want you to do. The difference of the values, the x values, x2 minus x1 squared plus x, no, this is a y, I'm sorry, y2, the difference of the y values, y1 squared. And then we just substitute in those values, so we get DE equals x2 is -2 minus x1, which is 3, squared plus y2 is -5. Minus y1 is 4, and that's squared. And then we just simplify, right? So order of operations, we have to do those parentheses first. So we're going to go here, -2 minus 3 is going to end up being -5 squared plus -5 minus 4, which is going to end up being -9 squared. Okay. And then we continue to do the order of operations, which would be the exponents. So negative square root. -5 times -5 squared is the same thing as -5 times -5. A negative times a negative is a positive. 5 times 5 is 25. Plus -9 squared. Negative times a negative is a positive. 9 times 9 is 81. And if you can see here, we're getting close to the same answers, like right there, except this has a square root over it already. And then we just add those 2 numbers, 25 plus 81, which is what we already did over there, and we know that that's 106. So there's our answer right there. And you get the same thing. So use the distance formula of the Pythagorean theorem to find the distance from D to E. And so we did it both ways right there. Awesome, awesome, awesome. Okay, let's go ahead and practice this again. Okay, this says right here, check it out, example 4a. It says use the distance formula and the Pythagorean theorem to find the distance from R to S. So again, I'm just going to highlight, we have to do both of these things, the distance formula and Pythagorean theorem to find the distance, right? So again, I want to go ahead and here is R, here is S. Let's go ahead and we're finding the distance right here. And so we have to create, this is all we have. We have to create a triangle. So I'm going to start here, and I'm going to move you go like in a horizontal direction over this way, and then I'm going to start up here. This one's the one that's bigger, and I'm just going to go down, and you're just going to find the vertical straight down until where they intersect, and they intersect right here, and that is my 90 degrees. So here's my right triangle, and since I have a right triangle, I can use the distance formula. This side that's directly across from my right angle, remember that's the hypotenuse, which is the distance that we're trying to figure out, and we're going to call that C, and the other two sides are the legs, A and B. So now we just need to figure out what the distance of A and B are. So we can do that just by counting, right? So we're here, and we just count all the way over to here. So 1, 2, 3, 4, 5, 6. So that means that A is equal to 6. It's always important to double check it. Make sure you counted right. You don't want to go through all that work and then just mess up on the counting. So 1, 2, 3, 4, 5, 6. Okay, perfect. And then B, we're just going to count up, right? So 1, 2, 3. So that means B is equal to 3. And so that's all we need. We know our A, we know our B, we know our two legs. Now we can figure out our C, our hypotenuse. So let's go over here and write down our Pythagorean theorem. A squared plus B squared equals C squared. Let's define our terms. A is equal to 6 and B is equal to 3. And then we just substitute those in. 6 goes in for A, so we have 6 squared plus 3 goes in for B. We have 3 squared equals C squared. And from here we just simplify, right? 6 squared is the same thing as 6 times 6, which is 36. Plus 3 squared is the same thing as 3 times 3, which is 9, equals C squared. We add 36 plus 9 is 45, right? Yep. Equals C squared. And then I'm going to go ahead and use that symmetric property of equality and just kind of flip it around. C squared equals 45. And get my variable on this side. And then I'm going to get C by itself, so I'm going to use the square root to both sides. I got my square root and my squared, so they cancel each other out like Fruit Ninja because they're inverse operations. So I end up with C is equal to the square root of 45. Now, 45 is just not a squared number on its own, but I want to see, okay, is there a squared number that is a factor of 45? Okay, so my squared number is 1 squared equals 1. 2 squared equals 4, 3 squared equals 9. You know what? I think 9 actually goes into 45. Yeah, 9 times 5. So I'm going to write the squared number first. 9 times 5. So the square root of 9 times the square root of 5 is actually equal to the square root of 45. And then I rewrite that 9 as 3 squared, because 9 is the same thing as 3 squared. And then I got the square root and the square. They cancel each other out because they're inverse operations, and it is Fruit Ninja time. So I end up with 3 square roots of 5. That's C, and C is the distance of RS, right? R comes before S in the alphabet, right? Yeah. RS equals 3 square roots of 5. And yeah, there we go. That is our answer using the Pythagorean theorem. Okay, not the distance formula. That's what we're about to do right now. So let's go ahead and find RS using the distance formula. So I'm going to go ahead and write down that distance formula. Remember, it's the difference of the x values, x2, make sure that's subscript, x2 minus x1 squared plus y2 minus y1 squared. Okay, cool. Now I need to define my terms. So this is my x1, that's my y1, this is my x2, that's my y2. It doesn't matter which one, just as long as, you know, this could be x1, y1, and this could be x2, y2. It's just, you know, you'll get the same answer either way you do it. Okay, now we're going to substitute those values in. So RS is equal to the square root of x2, parenthesis, what's x2? x2 is 3, minus x1 is negative 3 squared, plus y2, what is y2? Did I do that right? Yeah, x2, 3 minus x1 is -3. All right, cool. y2 is 2. Minus y1 is -1 squared. All right, perfect. We are going to, what are we going to do? We are going to simplify this. So we got to do the order of operations, parentheses first. So these two negatives become positive. So we have 3 plus 3 is 6, so 6 squared. Plus those two negatives become positive. 2 plus 1 is 3, 3 squared. And we are left with 6 squared. 6 times 6 is 36. Plus 3 squared, 3 times 3 is 9. And then 36 plus 9 is 45. So square root of 45. And that's really similar here, right? We got to put it in exact terms. So we already know 9 is a factor of it, and 9 is a squared number, so we can rewrite it as 9 square roots of 5. And we already know that 9 is the same thing as 3 squared. And then we fruit ninja, and then RS is equal to 3 square roots of 5. And we got the same answer both ways. Okay, one using the Pythagorean theorem, and then the distance formula. Boom, there you go. So our next problem right here, you're going to use the distance formula and the Pythagorean theorem. So you're going to do it to find the distance R to S, or RS, right? You're trying to find RS. So we're going to do this one more time, except this time I want you to try to do this on your own. So now it is time for you to pause your device, work this problem out, make sure you define all your variables, write all the formulas and symbols first, show all your lovely work. If you have any questions, it needs to look like this. All right, so use that as a guide if you need to. And go ahead and pause, and I'll see you in a little bit. When you get done, press play and we'll talk about it together. All right. Okay, let's do this. We are back. Let's go ahead and do the Pythagorean theorem first. Okay, what are we trying to do? What are we trying to do? What are we trying to do? We're trying to find the distance between R and S. That is what we're given, but we need a right triangle to use the Pythagorean theorem. So here we go. We're going to create a right triangle right here. Boom, shakalaka, there it is. We have our lovely right angle. Now we just need to find the sides. Oh, remember, directly across, that is our C, that is our hypotenuse, that is RS. That's what we're trying to determine. To do that, we need to determine what A and B are. So I'm just going to count over. So here, the distance is 1, 2, 3, 4, 5, 6. A equals 6. That is a leg. We got to find the distance of this other leg, starting from here, going all the way up there. 1, 2, 3, 4, 5, 6. So B is equal to 6. Perfect. Let's go ahead and write the Pythagorean theorem down. A squared plus B squared equals C squared. Define our terms. A equals 6, and B, was that 6? Yeah. Yeah. Oh, they're both 6. B equals 6 too. Okay, let's substitute them in. 6 squared plus 6 squared equals C squared. 6 squared is 36 plus 36 equals C squared. 36 plus 36 is, I'm pretty sure it's 72. Yeah, it is. 72 equals C squared. I'm going to use symmetric property of equality just to flip that from side to side. And then we want to figure out what C is, so we have to use the inverse operation of a squared, because C is not by itself. C squared is not by itself. It's, you know, we need C. So we square root both sides. Fruit ninja there, they cancel each other out. We are left with C. And we're left with the square root of 72. So we want to put that in exact form. So is there a squared number that goes in there? Yes, 9 does. So the square root of 9 times the square root of 8. 9 times 8 is 72, right? But you know what? There's actually a squared number inside of 8 as well, right? That's a factor of 4. So I'm actually going to rewrite this one more time. So square root of 9 is the same thing as 3 squared, right? But this 8, I'm going to write this as the square root of 4 times the square root of 2, okay? Because 4 times 2 is 8. So we have a little fruit ninja action happening there. We got that 3, and then the 4, that's the same thing as 2 squared, and then square root is 2, right? And then this square root and that squared cancel each other out. So we are left with 3 times 2, which is 6 square roots of 2. So that's what C is, which is our distance, which is RS. So RS is equal to 6 square roots of 2. So if you got that right, perfect, perfect, perfect. Okay, now that's the Pythagorean theorem. So let's go ahead and use the distance formula now. So the distance formula is for RS is equal to the square root of, what is it? X2, the difference of the x values, x2 minus x1 squared, plus the difference of the y values, y2 minus y1 squared. And we're going to define our variables. Okay, this is our x1, this is our y1, this is our x2, this is our y2. Then we substitute those values in. So we have RS equals the square root of, what's our x2? x2 is right there, 2. Minus x1 is -4. And all of that is squared. Oh, I forgot my parenthesis. There it is. Plus, oh, need to make this longer. Y2 is -1 minus y1 is 5. And all of that is squared. Okay, now it's just time to simplify. Okay, order of operations, we do the parentheses first. Those two negatives become positive. 2 plus 4 is 6, so we get 6 squared. Plus -1 minus 5 is -6 squared. And so that means RS equals the square root of 6 squared. 6 times 6 is 36. Plus -6 squared, which is -6 times -6. And negative times a negative is a positive. 6 times 6 is 36. And then we have RS equals the square root. 36 plus 36 is 72. And boom, we have the same thing that we had over here. Square root of 72 is the same thing as 6 square roots of 2. We already figured that out. So we got the same thing both ways, both times. So if you got that right, awesome job, wonderful job, and we will see you in a little bit for example 5.